Good afternoon and welcome everybody to today's webinar where we're going to have a overview and demonstration of the additive manufacturing extension within the Creo CAD suite. My name is Rob Romanowski. I am the Director of Sales Operations for 3HTI, and leading the presentation and the demo today is Paul Dye, who is an applications engineer and solutions consultant with the Virtual Center of Excellence at PTC. So we're really excited to have Paul on. He does a lot of these demos for us. He does a great job every time. So I'm real excited to have him help us out today. So during the webinar, this should take about maybe 20, 25 minutes with question and answers. If you have any questions, type them in the chat box. We'll try to answer them as we go along. And, you know, we're going to see some really cool stuff today from Paul and how to design using this extension, and really helping to optimize your designs, especially if you're looking to use additive manufacturing to print either a prototype or an end-use part. So Paul, you have control. We see your screen. Feel free to take it away, my friend.
Awesome. Thank you very much, Rob, for having me on, and thank you all for jumping on the call today. So yep, additive manufacturing, it is an extremely exciting area of design. It's really opening up the door to a lot of potential possibilities, and really is, I'll say, separate from what you would normally think of for 3D printing. Additive manufacturing is not just what you think of for getting a prototype built out, throwing it on a 3D printer to see what's going to look like. This is all the way up to full scale manufacturable parts that we can use for out in the industry for a ton of different use cases. So I'm going to go through and show how we tackle this from the context of Creo. And first thing I like to do is talk about it from a challenges standpoint, what we typically see out in the industry, just around the design process in general. And whenever we look at it from a design decision standpoint, a lot of the decisions that we typically have to make in the design process are driven by the manufacturing methods that we plan on using. So things like injection molding or milling, they just have inherent considerations that you have to take into account. And a lot of times it limits you in terms of the geometry that you're able to create, where a lot of designs just simply aren't possible to create using those types of manufacturing methods. It can also be then very costly or require pretty long lead times to even create the tooling that you need to manufacture products. There's a lot that goes into the equipment that we need to even begin into that manufacturing process in a lot of cases. And as the parts that we work with increase in complexity, so do those costs and lead times. And most times what we end up seeing is people over engineering designs just simply because it would be too difficult or too time intensive and probably too complex to optimize the part, but still be able to manufacture the model properly. So it means that many of the different things that we would like to improve upon, but just due to those limitations, aren't possible or just not reasonable. So what we found is that additive manufacturing can provide the solution to all those different challenges. And we put a lot of time, a lot of honestly effort and investment into Creo, specifically with the additive manufacturing extensions to give you the functionality that you need to start building up your designs with this new world of capabilities in mind. And one of the main areas that we're really focusing on here is the idea of lattices. And really, just to preface this as well, we put a lot of focus into the design of our parts itself. We don't want to just have the focus all be on the actual 3D printing process. We want to take a step back and say, hey, what can we do to these designs first and foremost to make them even better for 3D printing, and what can we really do when we don't have those type of limitations in mind? And lattice structures are really the key to this. Gives you the ability to create some very strong, robust geometry, but at the same time, you're able to save on things like material costs or even just make a design more visually appealing. And lattices in general are something that just simply wouldn't normally be able to be created in a lot of cases using standard manufacturing techniques. But for additive manufacturing, it's a piece of cake, not only to design and automate from within Creo, but also to put onto a 3D printer. And you'll see that there's a lot of different types and configurations that you can use with this. Essentially, every single release of Creo that we've had, we're adding more and more to these types of lattices that you can run with. Even coming up on the release of Creo 10, we're having more and more added in. So it's everything from more simple 2.5D lattices all the way up to full 3D lattices as well. So you have the ability to create all these different lattice structures, which take a lot of weight out. And so at the end of the day, you're maintaining that structural stability. And they're able to be integrated in seamlessly with our optimization and analysis tools in Creo. So it allows you to not only build out these lattices, but also start to optimize them depending on different design considerations, different constraints that you have. So really moving away from those over-engineered designs. And then once you've optimized the structure, take it into your analyses, see what type of stresses, deformation, temperatures, whatever might be important for you to improve on a design and really continue to optimize towards a better design overall. One of the cool things that we're able to do within Creo is actually take analysis results, and what we have something called a variable density lattice, which can actually thicken or thin the lattice depending on where you're getting stress values in the model. So it can be done automatically, and you can really have a very strong integration between those two separate areas. And again, just using the standard additive manufacturing extension, you're able to do printer tray optimization. So you could do it manually if you wanted to, or you could build out patterns. However, you might want to have those parts arranged into the tray, but also have the ability to do nesting optimization. This is where the system goes through and optimizes the placement of the parts from within the tray to give you the best possible orientation whenever it's time to print these parts out. And once they're built out, it's just saved as a Creo assembly file that you could work with later on. Now, everything that I've talked about is in our standard additive manufacturing extension, and we do have a separate option called the Plus. Now, this is if you have a metal 3D printer, you can move up to the additive manufacturing Plus extension. So this starts by giving you printer connectivity into many different printers that use the materialized build processor. This is what's used as pretty much an industry standard for metal 3D printing. And then once you have that printer connected straight into Creo, have the ability to manage each 3D printer, add new ones in, look at the jobs being sent to each one. Again, just do that right from the same standard Creo interface. Gives you the ability to rapidly define and build out different tray configurations, again, specific to the metal 3D printing process. Another capability that we have specific to metal 3D printing is the automatic generation of the support structures. These have a lot of considerations that you normally have to take into account, and we're able to go through and build that all into the design itself right in Creo. So many different configurations whenever you're creating these support structures to make sure that they're built out for things like easy removal, heat dissipation, even material savings. Again, all the things that are going to be important to us throughout that process. All right, let's go ahead and switch over and we can take a look at what some of these different tools look like from the context of Creo. And again, if you have any questions throughout that, feel free to drop that into the Q&A, and we can definitely stop later on if we want to get any of those answered as well. All right, so we can go ahead and jump into our demonstration here of the additive manufacturing extensions. We're going to be working with the data set that we have from one of our customers, Royal Enfield. This is going to be the motorcycle assembly that we've been working on as a designer. So we can go ahead and open that up here. In my case, there's a couple of different areas that we want to focus in on here. So let's start first and foremost down at the muffler and the exhaust assembly. If you hide the casing here, what we can do is grab one of the internal parts here that we can go ahead and work with. Now this piece here is the start of the sound attenuation on the muffler, and the current design is fairly simple in this case. It may have come from a previous design, and the idea is that it's probably very straightforward to manufacture. Taking a look at the cross-section view, you can see that it's essentially just holes going through a straight cylinder here. So that's the existing system and really the start of our exhaust control, but maybe we want to get to something different. Maybe we now have a 3D printer on site that we're able to work with, or a third party that we want to go through and try out some new designs on. So what I'll do first and foremost is just clear out that center area. This is where we want to use our new latticing capability here to see what I can come up with. This is just available right out of the engineering tab. You can just go ahead and select that and jump into a lattice. And these can range anywhere from very simple to very complex. But the idea is a 3D printer has no problem creating this type of geometry. So this is going to start simply as a lattice feature, just first and foremost defining the lattice region, which is more or less the boundary or the area where the lattice is going to exist within. And then from that point, what we're able to do is select the cell type that we want to use. In this case, I want to try one of our newer stochastic lattices, where it's going to be more of a randomized ball and beam structure throughout here. And with any of these, regardless of what cell type that you're working with, you have a lot of different options and parameters that you can change. You can change the cell size, the nodes, the diameters, cross section, very low level granular control. Change that around so you're happy with the structure that you get back. And once you have that set, you're able to visualize what that would look like here in the part. Go ahead and get that preview here. And if you like what you got here, you could go ahead, accept that, and start to prepare it for 3D printing. If you don't like what you got, or maybe you just want to go through and try a couple different things out, you can go right ahead and do that as well. So let's take a step back here and try more of a 2.5D design if you wanted to simplify things down a bit further. And with this, you still have a lot of options for the cell size, the shape, options for exactly how it's being created there. If I wanted to work with this a little bit, say I wanted to make the wall thickness a bit thicker, or round off the inner radius just to make sure that that flow is a bit smoother. You just lay that out here in my options, and you're always going to get an instant preview of what that's going to look like on one of your cells. And again, at any point, I can have the system show me what this is going to look like overall, or even after it's created, still, able to work with it, analyze it from that point. Another one that I could show here as well is what we call a formula-driven lattice. So these are very powerful, and it's essentially what you're building out here. It's going to be a little bit more specific to metal 3D printing, but these have fully self-supporting geometries. So that means that all the geometry that's being created, no matter the orientation or how it's been going to be built out, it does not require the use of support structures. So again, this is completely changing the game for all the rules for what something like this, like a muffler center section could be. You're able to create structures that just simply weren't possible to create in the past, and they're able to look a little bit more like this here. Go ahead and lay this out here. And you can see one of these cells here is just, something that would never be able to be created on a 3-axis mill, right? But for throwing it up on a 3D printer, again, very easy for it. Right? And if we like what we have here, we could go ahead and accept that design, and it simply gets built out as a lattice feature here in Creo. So again, design that's something that could only be manufactured with additive, and it's done by taking advantage of all the different advancements that we've had in the world of additive, whether it's for prototyping all the way up to full scale manufacturable parts. So that's the first main capability that you're working with in the additive manufacturing with the lattice feature. And again, it's something that we're constantly making improvements to, and we're always seeing new types of lattice cells being built out, and something that we're going to continue to further expand upon into the future. And from here, let's go ahead and move now to the printing of the actual parts. So let's move up here to the front end of the assembly. Maybe we're also planning to print the outer case of one of our sub-assemblies. And let's pull this up in the part itself. Now, this is actually a fairly complex piece. It would normally require a lot of work to cast and machine all the different holes that you see here and all the features, or even machine everything from a stock piece. So what we'd like to do instead is use additive manufacturing to create the piece. Now, what this does first and foremost is actually allow us to work with materials that might not normally do very well with something like a casting, but we have no problem whatsoever using on our metal 3D printer. So the process that I'm going to go through and show here now is what we would really do for something like this is start by 3D printing the main stock piece and then finish it up by doing a bit of machining to clean up some of these different surfaces. So that's what you're seeing here in yellow is any of the features that would be machined off later on. So I'm rolling this back so we could just see the stock piece that we would start with from the 3D print. So anywhere that you see in yellow would actually be cleaned up with a machining process. Just any of the spots that might have very low level tolerances that you need to get to, you can go through and again have the main stock piece 3D printed where it gives you a new type of material to work with, does it a lot faster. And then instead here, just go through and clean up some of these small connection bits with our machining processes. All right, so now that we have the piece that we're planning to 3D print, we can go ahead and set up the build tray and the build direction for the print. So first thing I'll set up is a plane that's going to act as the base for that build tray. That's where we're going to print from. And then I need to figure out how we're actually going to position this piece in the tray. Because if I'm trying to save on things like scrap or material waste, I definitely want to cut back on the amount of support material that I'm generating. Now, the best way we have of doing this in Creo is using a build direction analysis. The first thing that this study looks at is the critical and subcritical angles. That means anything that goes beyond those angles would require the use of support material. We can have that highlighted right up in the model to see where our problem spots might be. And instead of us trying to manually do this and try out different positions, to determine the best orientation, we could just simply let Creo do the work for us here. All right, and now Creo is going to take our part with those critical and subcritical angles, and it's going to go through, iterate, and figure out what the optimal position to print that part in. And there might be some parts that you work with where the optimal print direction might be pretty straightforward or obvious. It's more of a boxy shape. But if you're working with pieces like this, production parts where it's a bit more round or has a bit more complexity on the inside, it's probably not as obvious to figure out. So we can let Creo do that work for us. It's going to go through different orientations until it converges on a solution. And what you ultimately get here is an orientation that we probably would not have thought of on our own, but is going to be optimized for the part that we're working with. And you can see the end result here is simply going to be a coordinate system that we can now use to print from whenever we go through to set up everything for our particular printer. And that's what I can go through now and do. So we can go through the process of preparing that part, laying it out on our printer tray. And again, this is actually the printer tray that we would have out on the shop floor. Creo can be linked up into all these different types of printers where we can send our prints directly from Creo to get printed. So go ahead and pull this into our tray. And you can see all the different printers that we work with. In my particular case, I'm going to be working with iMaterialize, but we also support direct interfaces with 3D systems as well as Materialize. All right. Once we have the specific tray and the build tray selected, we can go ahead and arrange the part onto the tray. So that's where we're going to use the build direction that Creo went through and optimized for us over in the build direction study. And with that build direction assigned, we have the ability now to determine how the support structures are going to be generated. So this is taking into account things such as the support angle, a lot of other parameters that we can take into account here and lay out. In our case, let's just go ahead and generate the support structure. So again, not something that you have to ship over to another program. You could just stay right here within that same interface. And even if the part were to change, if the printer settings change, you're able to update the support structures without any hassle. Very easy to go through and make those changes. So you can visualize what those support structures look like. And in my case, this was actually done with a pretty low self-supporting angle. Maybe in our case, our printer requires a self-supporting angle of 45 degrees. We can go ahead right back in here and change to a different support structure profile. It's very easy to switch between those different profiles, where in this case, now we have a different angle. And with that switch, let's go ahead and regenerate the supports. So that's the idea. You can have a template set up for one printer, different settings for another printer if you'd like to. And now based on that build direction and the increased self-supporting angle, you can see it's going to require a bit more support material there. All right. Now from here, what I'm able to do is take that part, take the support structures, and we can preview and visualize the slice file right here from within Creo. That's called a CLI file that we can generate and either share off or just view right here from within the same interface. Creo is going to go through and generate however many slices that it would take to create our design based on our printer. And once it finishes going through each of those slices, we're able to display each and every slice that's going into creating the design. If we want to get a better view of that, let's switch to our orientation and switch it to a top-down view. Just gives us a better clear of what each of the slices are going to look like here. And what this is allowing us to do is spot check and make sure that we like, or at the very least understand, each part that's going into that printer. And if there's any geometry that you wanted to change, it's very easy to go back through and make changes to what we need there. And that's one of the biggest things to notice, is that every single step that we've taken in the entire process, it's been in the same interface, whether it's for building out the lattices or even starting from a fairly standard part, be able to do your preparation for 3D printing right from within Creo. So we started with the base model, we optimized the build direction to cut down on the support material, we set up everything and connected to our particular printer, generated and edited the support structures, and then finally visualize every step of that 3D printing process here. And we never had to leave Creo to do that. So whether you're building out for plastic or metal 3D printing, additive manufacturing in Creo is really taking us step by step through that entire process and making sure that we're ultimately sending out the best models possible to those printers. All right. So that takes us through a lot of what I wanted to show, at least from the context of Creo and working through that interface. And it really is giving us a ton of value of working with. So one of the biggest areas that we see is a reduced time to market. What you're able to do is cut out a lot of the process that would typically be required to get your parts from your design software to manufacturing. But with additive, it makes it so much faster. Almost, everything is all done from within Creo. You can get into production that much faster. We're accelerating new product introduction. So not only are you getting be able to go through and try out designs faster, but you're able to try out lots of designs that you probably only would have thought about in the past, but it's easy to work with here from within Creo. And that's really what we want at the end of the day. We want to make high quality parts, be able to innovate throughout the entire process, try out designs to your heart's content, right? We don't want to have to worry about whether it's able to be milled or casted or anything like that. And at the same time, reducing many of the costs that are associated typically with manufacturing. And that's all just using those additive manufacturing extensions. Right. And one thing I'll mention here as well is that there's tons of different enhancements, not only just back in Creo 7, obviously, in Creo 8, Creo 9, and all the way up until our new release of Creo 10. So a lot of different things that are being enhanced there, and something that you always want to check back on. So yeah, with that, that pretty much covers everything that I wanted to touch on.
Excellent. Thank you. Thank you, Paul, very much. So if you have any questions or want to see more of a specific demo to parts that you are creating regarding the Creo Additive Manufacturing Extension, you can get in touch with us at info at 3hti.com, or you can just respond to the email that you received as the invitation for this webinar. Those come directly to me as well. So want to thank you guys for being on today. Paul, thank you very much for the demonstration and the overview. And we will be back with another webinar next week, which will cover, drum roll please, webinar next week will look at, get in February, Creo Simulate and Creo Simulate Advanced. So we're going to start looking at simulation tools with Creo, extensions that are available for Creo for simulation. We'll look at some of the ANSYS tools. We'll look at Creo Simulate next week, and also we will look at some computational fluid dynamics with Creo Flow. All this in February. So thanks again, Paul. I appreciate your help, and most importantly, thank everyone for being on today. The recording will be sent out within the next couple of days. Thanks, everyone. Take care.